Hey fans, let's look at this question on moments. So let's take a moment to read it and let's work out some answers. So you're told that the drawbridge is inclined at some angle theta and it is a uniform rod. So that means that the mass is going to be at the center of the rod. The weight of the rod is 8,000 newtons, so G is included in that. And the horizontal force, which is this force here, 6,000 newtons, is applied to the top of the drawbridge, and you're told that the drawbridge is rising. So in other words, this bridge is moving up, it's being lifted up. So we're just going to make the diagram a bit clearer here. So let's call this point here the pivot point P, and you've got the bridge going up like that, and we've got 8,000 newtons coming down, and we've got 6,000 newtons in the horizontal direction. Now theta we don't know, and we need to prove that tan theta is 2/3. So let's take moments about P, and we have to be careful here because it's not in equilibrium. It's not stationary, the thing is moving, and we can see that if we were to show the movement, essentially it would be moving up in this direction. This whole bridge is basically as it's moving up, so it's being lifted up, assuming that that was the starting position and that's where it's going to end up, facing up. So we're still going to use this idea of equilibrium, but we need to be aware that technically the clockwise moment is greater than the anti-clockwise moment. So the clockwise moment is the 6,000, the anti-clockwise is the 8,000. So let's resolve these forces. So taking moments from P, because we don't have the length of the bridge, we can just call the length 1. Relatively speaking, we can pick any length we want, but so in this case that's going to be a half, and that's going to be a half unit. So you can call it half a meter if you want to, doesn't really matter, it'll be all relative. So resolving the 6,000 Newton force, we are going to work out the perpendicular force there. Now theta is given to us here, that is going to be equal to this angle here, so this is going to be 6,000 sine theta. And then we need the perpendicular here as well. So in this case, this angle here is going to be theta. So this is going to be 8,000 cos theta. So now we have all of the perpendicular forces to the point. We're going to take moments. So moments about P. And we're going to say this distance here times that force, and that's going to be greater than this distance here times that force. So 6,000 sine theta times 1, the distance is 1. I'm not going to write the 1 there, it's just going to be times 1, is equal to, now technically it's greater than, so maybe we should use an inequality here. So that's going to be greater than, and then we are going to do half times 8,000 cos theta. We're now just going to rearrange it, and then hopefully we're going to get tan theta equals 2/3, and you can see that's pretty much going to happen here once we simplify it. So 6,000 sine theta equals 4,000 cos, sorry, not equals, is greater than 4,000 cos theta. We're going to divide both sides by 2,000, so you get 3 sine theta is greater than 2 cos theta. Divide both sides by cos, and we get 3 tan theta is greater than 2, and then divide both sides by 3. So we get tan theta is greater than 2/3. And that's your proof. Hope that was useful. Smash the like button, hit subscribe.